Hi students, today we have to discuss the application of Newton's second law. In the previous class, we discussed about the statement of Newton's second law, and also we found the mathematical equation of Newton's second law. So today, what are the applications of Newton's second law? Okay, look at the board. A fielder in the ground gradually pulls his hand backwards with a moving ball. It reduces the impact of catching because it increases the time and then reduces the acceleration. Okay, a fielder in the ground gradually pulls his hand backward with the ball. It is to increase the time of catching. Okay, it is to increase the time of catching. That helps to decrease the force. Where we get it? It is from second law equation. M into V minus U by T is the force. So when we increase time, when we increase this time of catching, time of that event, it will decrease the force. That means the force applied by that ball on his hand. So the impact produced by the ball decreases when we increase the time of catching. That is the point. Okay. Also, another application. The athletes are made to fall either on cushion bed or a sand bed. This is to increase the time of athletes to stop after making the jump. When an athlete jumps on a ground, in the case of a high jump or long jump, we provide with a cushion bed or sand bed. It is to increase the time of stopping. That it helps to increase the time of athletes to stop. Okay, it reduces the impact produced by athletes and ground. Okay. So these are the two applications of Newton's second law. Then define one unit of force. Define one unit of force. Okay, one unit of force is defined as the amount of force that produces an acceleration of 1 meter per second square in an object of 1 kilogram mass. It is the force produced by an object having mass 1 kilogram, and also the acceleration should be taken as 1 meter per second square. When we take an object of mass 1 kilogram and we are moving that object with an acceleration of 1 meter per second square, then we should provide. Then how first law can be derived from second law? Okay, how first law of motion can make from second law. From Newton's second law of motion, we want to get the first law. Okay, we want to check how the process is. First we take equation of Newton's second law. That is F is equal to ma equal to m into v minus u by t. We already know it. Then rearrange it. Place this t into here. Okay, F is equal to m into v minus u by t. This t is in division part, so we want to take this t into the LHS. Then we get Ft is equal to m into v minus u. Okay, then we providing the external force as 0. We providing the external force as 0 because the statement of first law is when there is no external force, the object remains in that state. So we providing no force, that is F is equal to 0. Then we get 0. This F is 0, then 0 into t is also 0. So 0 is equal to m into v minus u. For getting the LHS 0, we either m is equal to 0 or m into v minus u is equal to 0. To get the LHS 0, we should provide m is equal to 0 or v minus u is equal to 0. Either this term either this term should be 0 to get the LHS as 0. So m is not 0 because it is a property of an object. This top has a mass. It is not 0. So we cannot make m as 0. So m is not equal to 0. Then v minus u should be 0. That is v minus u is equal to 0. To get this value, we then rearrange this equation. V or this term take to LHS. Then we get v is equal to plus u. That is v is equal to u. We get v is equal to u. What is it? V is the final velocity and u is the initial velocity. From this statement, we get the initial velocity is equal to final velocity. If f is equal to 0, then initial velocity is equal to final velocity. That is, the object doesn't have any motion. It means that the object continue its initial velocity when no force is applied. Okay, that is first law. When no force is applied, the object remains in that velocity or rest. That is the first law. So from second law, we derived first law. Okay, then we have to find the answer of this question. First, read the question carefully. A constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of applied force. Now, if the force was applied for a duration of 5 seconds, then what would be the final velocity of that object? It is the question. Read it repeatedly and find what are the given quantities. First, read it. The constant force acts on an object of mass 5 kg. We get the mass of that object. Given that m is equal to 5 kg. Okay, then a duration of 2 seconds. That means the time is given as 2 seconds. Then it increases the object's velocity from 3 to 7. That means initial velocity is 3. U is equal to 3 meter per second. Then to 7. That means final velocity is 7 meter per second. Then find the magnitude of f. F is equal to what? It is the question. F is to find. Then now if the force was applied for a duration of 5 seconds. If the applied force was 5 seconds. If t is equal to 5 seconds. Then what would be the final velocity? What is final velocity? Then find the final velocity. That is the question. So first find this applied force. What is the equation for F? F is equal to m into v minus u by t. F is equal to m into v minus u by t. That is given. So from Newton's second law, we know m into v minus u by t is equal to F. Then substitute the values. M is given 5. V is given 7. U is given 3. Then T is given 2. Then 5 into 7 minus 3. 7 minus 3 is 4. 4 into 5 by 2. That is 20 by 2 is equal to 10 Newton. The applied force is 10 Newton. We get the answer. Then in the another part, if T is equal to 5, then find final velocity. We only know the equation from second law. From second law, F is equal to m into v minus u by t. That is, we have to rearrange this equation to get v. So then this t take into the LHS, then Ft is equal to m into v minus u. Then this m is take into this side, then we get Ft divided by m is equal to v minus u. Then just invert this equation. Just invert. V minus u is equal to Ft by m. V minus u is equal to Ft by m. Then just invert this equation. Just invert. V minus u is equal to Ft by m. V minus u is equal to Ft by m. V minus u is equal to Ft by m. Then just invert this equation. Just invert. V minus u is equal to Ft by m. V minus u is equal to Ft by m. Then just invert this equation. Just invert. V minus u is equal to Ft by m. V minus u is equal to Ft by m. Then just invert this equation. Just rearrange this equation to get v. That means we want to move this v into this side. That is v is equal to ft by m plus u. Ft by m plus u. Then substitute the values. F is 10, T is 5, M is 5, U is 3. Then what is the value? V is equal to 10 plus 3, that is 30 meter per second. It is the answer. Okay, the final velocity of that object would becomes 30 meter per second. Then we have to find the answer of another question. The question is, which would require a greater force accelerating a 2 kilogram mass of 5 meter per second or a 4 kilogram mass with 2 meter per second square, which needs a greater force, that is to find. We know the equation as F is equal to ma. Then in the first case the mass is 2 and acceleration is 5. Then just substitute it. M is 2 and acceleration is 5 and we get F1 as 10 Newton. Then another question, or 4 kilogram mass of 2 meter per second. Mass is 4 kilogram and acceleration is 2 meter per second. So F2 is equal to 4 into 2. We get 8 Newton. So which is greater? F1 is greater than F2. That is the answer. F1 is greater than F2. That is the answer.